Good morning. This morning's track is Enabling Technologies. I'm a systems engineer for Lockheed Martin at the Johnson Space Center in Houston, Texas. She's participated as a human test subject in the Lunar Mars Life Support Test Project, where she lived and worked in a sealed chamber for 60 days as part of a 4-person crew. Her primary responsibilities during the test included coordination of the medical experiments and logistics. Prior to the test, Karen designated biomedical hardware for the Human Research Facility for the International Space Station. She received her BSEE from the University of Maryland, College Park in December 1995. Karen?
Well, as mentioned, I was a human test subject inside of a sealed chamber for 60 days. There were a few other people in there with me. We had a crew of 4 engineers. Terry Tree, an employee of NASA, was our crew commander. Frederick Smith was a systems engineer. He's also an employee of NASA. I'm a Lockheed Martin employee, and I was the medical experiments coordinator. I also handled logistics and scheduling of crew activities. And Dave Stott, who is a systems engineer with Lockheed Martin. Today I'd like to tell you a little bit about the test, also a little bit about the Advanced Life Support Division at NASA. We hear a lot of chit-chat. Looks like it's going the other way. I'll be talking about the Advanced Life Support Division at the NASA Johnson Space Center. There's been a lot of talk at this conference, of course, about Mars or bust. For any folks who want them, I have some extra pins, and I have some cards with our webpage information on it. We do have the directors in our life support division now at Johnson Space Center now wearing these pins, so they have a big goal of getting us to Mars, as well as Mr. Golden, who received some of our crew patches and some of these pins as well. I'm going to have a little bit of an AV interesting technical exposition up here as well. Single-handed, not a lot of room. Of course, the goal of advanced life support is really to provide self-sufficiency for human beings while they're in a space environment in order to continue to perform medical experiments and collect good scientific data. If you think about being at home, you don't want your plumbers coming in every day to tinker with your faucets and your plumbing or your air conditioning. That's something that we really feel is unacceptable, and for long-term space flight, certainly even on our space station on the shuttle, that's unacceptable as well. We want to have systems that function well, that do not need a lot of high maintenance. Astronaut time is very expensive. If you think about sending one person into space for 1 year without doing any recycling at all, what you find is that the number one item you're carrying with you is water. 86% of your cargo will be water, over 22,000 pounds or 11 tons of water. Much more certainly than food, crew supplies, or any type of maintenance hardware you would need for your systems that are keeping you alive. So really, how do you get around that? How do you carry what you need? You do some water recycling, and you also recycle your air. The Advanced Life Support Division decided to take a look at several different tests, and they did this in a phased approach over the last few years. In 1995, we had one gentleman living for 15 days inside of a closed plant facility. He got all of his oxygen from the wheat plants inside the facility, and he supplied the CO2 necessary to keep these plants alive, and he lived in there for 15 days. His name is Nigel Packham, and he is a scientist with Lockheed Martin. The next test was in the summer of 1996. This was a 30-day closed chamber test. This is what we call the 20-foot chamber. This is also the chamber where I stayed. What you see here are the second and third levels of the chamber, and you can't see the first level, but it's down below. These folks on the second level are the prime crew that went in for 30 days, and the folks on the third level were their backup. Should anyone be injured or should anyone not be able to complete the test, we were allowed to leave without any explanation whatsoever, and they would send in a backup crew member. This chamber is a circular steel can. Basically, it was used as a pressure chamber for the Skylab Medical Experiments altitude test back in the early 70s. There were 3 astronauts in here testing Skylab hardware. Now it has had a middle level added. The top level was actually removed. The second level was added. The top level was put back on. It's basically like a large can, 20 feet in diameter and 3 stories. Okay, this is a pretty busy slide, but basically I'm going to use this just to tell you a little bit about each level of the chamber. And this is the configuration of the hardware for our 60-day test, and then I'm going to show you a video of the footage of us inside the chamber. The first level of the chamber down here is comprised of a main living area and water reclamation systems, and a small airlock on the front end which had our stationary bicycle and a resistive exercise device. We call that the spa. We did have to do exercise 6 days a week, which of course is a lot more than we normally do. The water recovery system was broken down into 2 main parts. One system recovered our urine and cleaned up our urine, and then took that and put that in a common hygiene waste tank. And then other systems took all the water from the hygiene waste tank, which was not only the recovered urine, but also your shower water, hand washing, brushing your teeth, shaving, and any wastewater that might go down the sink, or maybe any leftover juices or other fluids from foods that might go down the sink. That water was then cleaned through our systems in a multi-filtration system. We added a little bit of iodine as our biocide instead of chlorine like you would have in your tap water. And then we ran it through a test loop to make sure it was nice and clean, which it was. And it's actually cleaner than the water that you get out of your tap. NASA, of course, has certain standards that they have to maintain. The first level also housed our common area where we had a flip-down table, and we had dinners, meals there. We did some work there. We had a large control computer system which handled some of the automation of our systems inside. The second level housed most of the air systems. This was the noisiest level of the chamber. We didn't spend a lot of time up there unless, of course, we were tinkering with the systems, a little bit of maintenance. We did also have a lab bench up there. We were tasked to perform 12 medical experiments during the course of the test, which we completed all of them successfully. And the third level of the chamber was our crew accommodations area. We each had a private room to sleep in and to keep all of our personal belongings in, and also our workstations, which functioned not only as computers, which were wonderful computers, but also as televisions and 2-way audio-video communication with our folks in the control room who were out there supporting us in all 60 days, 24 hours a day through the test, but also friends and family and other coworkers who might like to come in and sit in our visitors viewing area and have a 2-way video conference with us. Friends and family were allowed to come in at any time during the day, any day throughout the test, and we were also invited to have them bring our pets in and have them come into the viewing area if they like. Nobody did that, but I didn't want my kitties in there. I thought it would be much more traumatic for them. I'd like to go ahead and show the video now. Now, normally I have my 3 tank buddies here with me, but I don't today. And we all look alike. We usually wear our crew shirts. And we all kind of talk alike. And so yeah. Thank you. So as a matter of fact, it's been pretty hard to keep us apart. We're a very successful crew, a lot of good selection choices ahead of time, and a lot of good preparation. For the first 2 weeks after the test, including the weekends, we were together after we got out of this tank. This is our crew patch. It's kind of neat. It's actually got the 6-0 for the 60 days, which I didn't even notice until partway into the test. It's got the Earth and the can there, and then the space station, the Moon, Mars, and beyond. This test was studying some developmental hardware for the space station, but it's also the Lunar Mars Life Support Test Project. And then, of course, our prime crew members and our backup crew members, and NASA, and our phase. This was stuck in between phase 2 and phase 3. Here's another view of the can or tank, whatever you prefer. To get an idea of the high bay area. This is in Building 7 at the Johnson Space Center. And there we are, getting ready to go in. A lot of the people actually out in the high bay are support people. And support people come in many forms. First, we had a handshaking ceremony there with our center director, Mr. George Abbey, and the head of engineering director at Johnson Space Center, and some other folks who came by to wish us well. We said, thank you, everybody, thank you, thank you, thank you. And there's a lot of thanks. All these folks out here are a combination of family and friends and other folks who really helped to build these systems up and make sure they were running. There were a lot of pre-test checkouts that had to be done, a lot of new hardware that had to go into our control room to make sure that most of our systems could run properly. And of course, all the cameras inside. We had cameras on all levels of the chamber so that we could be monitored 24 hours a day. And this is peeking in through the porthole on the side near our spa. You can see the little seat of the exercise bike. Again, here's some of our technical folks on the outside sealing up the door. That was the door there. We get the thumbs up, and then you get a little peek in, and that's all folks could really see of us in there as we embarked on our 60-day mission. This is the first level of the chamber. It gives you a little bit of an idea of some of the cabinets and the hardware. About 1/3 of the first level was taken up with water reclamation hardware. We had a fairly normal galley. Here's a gooseneck faucet and sink and a flip-up counter, a couple of microwaves, and a little bit of pantry storage underneath the microwaves. The sink functioned basically normally like your sink would at home. We had a hot water and a cold water faucet on this particular sink. But on our other sinks in the bathrooms, it was all a measured dose. Basically, you hit a button and you get so much cold water. You'd hit a different button and you get a little less water. The urinal rinse was only about 125 mils, and a hand wash or brushing our teeth was about a half a liter. Television VCR, on that television we almost always had the control room channel on there so we could see our people outside. This was a pantry area. We used a space station-like menu. Our station is going to have many freezers up there for their food. They're going to be doing less of the dehydrated foods and more frozen foods. So we basically got to eat TV dinners all the time, which is kind of fun. We panned past a transfer lock and some items. We had 3 transfers a day for items in and out of the chamber. And this is just an example of a sensor. We had a UV sensor in there for sparks or fire. We were in an oxygen environment, and sparks and fire are not a great thing to have in that environment. We also had smoke detectors and combustible gas detectors. And should there be a fire, we had a pretty powerful water deluge system that would fill that tank about a foot per second. And if you were trying to exit, you did not want to get a limb hit by one of those water spouts. It could probably break your arm. As we moved into the bathroom on the first level, we had a commode and a urinal and a shower and hand sink in here. Our fecal waste was bagged and actually sent out of the chamber. In this particular test, we did not recycle the solid wastes. This is a urinal funnel. And this is where the urine was poured down into, and inside of that funnel were some chemicals to begin the breakdown process of the urine. And then a little flush water spout and a barcode data logger. These things are great. We had to measure every void of urine. We had to measure the volume every time we urinated, and we had to pour out a small sample to be sent out to the docs so that they could track any calcium deposits that were coming up in our urine.
Was there a camera there?
No, but the camera outside could pan to go into the bathroom should they need to do work in there. You saw the hand sink, and of course here's our shower buddies. And our shower, we had a flow meter in the shower. This was kind of fun because the flow meter was one of the things that needed a little work. We showered with about 3/4 of a gallon of water. That's about 1 case of beer, if you want to put it that way. But if the flow meter wasn't quite sensitive enough, you could shower with all your water for the whole day, for the whole crew. So we worked on the shower meter. We got that working a little bit better. And here's another view of the first level with our table area. There's Fred taking a look at water data. We, of course, tested our water every day, and the data was sent in to us to take a look at. Our stairs are kind of steep. You walk up and you slide down. And we went up and down 2 flights of stairs probably about 25 to 35 or 40 times a day. Here are some of the air systems. This was a system for removing the carbon dioxide out of the air. That was the first thing you need to do. The next thing you need to do is take that carbon dioxide and burn it up. And we would mix that carbon dioxide with hydrogen, bust it apart, vent the methane gas out of the chamber, and then send water to our oxygen generating system right here, which would use current to bust that water molecule apart and send oxygen into the cabin area of the chamber so we would have oxygen to breathe. Here was our lab bench area in the back. And we stored quite a bit of our medical equipment there and performed some of our tests there, although it really functioned more as a central storage area. And we had a lab refrigerator and an incubator as well, because we processed some of these samples that we were testing for bacterial growth real time right in the chamber. And of course, that's important to do on the space station or on a ship that's traveling to Mars. This is really to give you an idea of the complexity of some of this hardware. These are each individual cabinets that house this hardware. And of course, our technical guys in there had to make sure there weren't any leaks and all the fittings were tight and all the temperatures were right. This was a squawk box, a communication box. We had them on all 3 levels of the chamber and also to our control room on the outside. Folks asked us about the air quality. The air quality was pretty darn good. Very clean air, and the only odors we got were occasionally food odors would come upstairs. And one time, one of the guys outside transferred something in, and I think he just put on a lot of cologne. And cologne odor came in. Other than that, you don't smell much of anything in this chamber. This is the 3rd level. One thing that's kind of remarkable is all the white walls. And this is sound insulation. This is a steel can we're living inside, so we need a little bit of insulation. This is pretty noisy in there. And this is one of the crew rooms. There's Dave. And yeah, he's a great engineer. It was wonderful working with him. Like I said, these computers were not only workstations, but they were televisions and also 2-way audio-video communication. He had an upper bunk in here, and you can see some clothes racks. There were also crew lockers in these rooms and shelving for storing things. This is an egress winch. If any crew member should be injured, we would remove the grates underneath. First, we hook them into a harness, and then remove the grates. This was important emergency training, and then drop them all the way down all 3 stories of the chamber. We were not trained in emergency medical types of treatments. We were right across the street from the clinic, so their emergency folks would have come in, or a local hospital would have come in. Here's the half bath upstairs, and this was kind of nice for a couple reasons. Number one, when you wake up at 3 o'clock in the morning, you really don't want to traverse those stairs all the way down to the 1st level. And second of all, we did have 4 crew members, and sometimes showering and using the commode downstairs could take quite a while. Everything took a little bit longer in this chamber, so we want to have a second bath. And again, our data logger for all of our urine samples. There's the urine funnel and the rinse cup, and some of our collection containers for collecting those urine samples and sending them outside. This is our commander's room, Terry Tree. And again, you get an idea of the range of personal items. The personal items were important. You really felt like when you went into your room and you closed that door, that was your own little space to be. And the rule was, when the door's shut, you leave it alone. That was the only rule that we had in the chamber. And folks spent private time at different times up in their room, and you could do that whenever you needed to, and it worked out very, very well. This is one of our water filtration systems here, and Dave is about to perform a filter change-out. This was the least desirable task in the chamber. I had not learned how to do this. I was not that familiar with the multi-filtration system, so poor Dave and Fred had to do this all the way through the test. I believe they did this about 3 or 4 times. About every 15 to 17 days, the filters in this particular unit were changed out. I'd like to take a minute and just talk a little bit about our water. We went into this test with 3 tanks of water, basically, each one about the size of a bathtub full of water. We used 1 tank per day. One would be in use. Another one would be tested for microbial growth, and the other one would be our fill tank. We turned these tanks over. We recycled the water in these tanks 17 times during the test, or a total of about 3 tons of water was cleaned by this water system. Each day, we had 17 pounds of water, which I said is about, would fill about one normal bathtub. And since space station is going to have some animals up there for research, we had to simulate the amount of water animals would use. So the first thing you remove from that 17 pounds is the animals, 17 gallons is the animal use. When you get done with that, you figure out how much water is left. You've got less than 4 gallons per crew member for all the water they use in a day. If you break that down into like cases of soda, that's about 3.5 cases of soda worth of water. Now your shower is going to take up one of those cases, and we were required to shower each day. We were providing dirty water and dirty air for these systems. Once you've done your urinal flushes, your hand washes, you've brushed your teeth, maybe you've shaved, that takes up about 2 cases of soda a day. That's gone. And really all you have left are about 2 6-packs of drinking water a day and for use in your food. And also, if any of it happens to be wasted. So just one other note on that, the humidity was less than 50%. So we did drink a lot of water in this test. Fred is doing a transfer. And that tank that's coming in was a brine tank. And that tank plugs into our urine system. And that will collect all of the solids that come out of urine, the different types of salts and materials in there that we don't want to send into a regular hygiene waste tank. This needs to be changed out probably about every 30 days. So we really only had to do this once. And we had made a decision up front we would not do this particular type of change out in the chamber. This would be very, very, very smelly. So the dirty tank was sent out. Our outside folks were great, weren't they? So we sent the tank out, and they put in the new filters and sent it back into us. Another thing that was interesting that we were able to recycle, of course, was the desiccant in our pumps. You want water in your system, in your pipes, but you don't want water in an oil pump. So when you have water, you have to make sure that it goes to all the right places and to none of the wrong places. And this desiccant, we were actually able to remove from the pumps and send outside, and they could bake that out and remove the moisture from it and send the desiccant back in. And you're going to want to be able to do that on a long duration flight. Desiccant can be kind of heavy, and you don't want to be carrying tons of that with you. I coordinated the medical experiments. We did complete 12 medical experiments in test, and this is critical because you want your astronauts to be performing experiments while they're up there. This was a device used to sample the air in the chamber and to test specifically for bacterial growth. Crew members certainly don't want to be breathing in bacteria. We basically had a small metal plate with holes in it and some agar in a petri dish, and the air would be forced over the petri dish and would move out of these holes underneath. And we would actually capture a 4-minute air sample. And this was done several times throughout the test on each level of the chamber. We could then take these, grow them in the incubator, and check for bacterial colonies. And our air was clean all the way through the test. This was great. We also had medical experiments broke down into 3 main categories. Basic crew health, where we did things like bacterial monitoring. This is a surface swab. Testing for bacteria on surfaces. We also collected our urine, we collected saliva samples, and we tested the water for bacteria as well. We had a food study, a sleep study, an exercise study, basic crew health types of things. The next category of medical experiments had to do with psychological aspects and habitation of being in a confined situation, close quarters, working and living together in close quarters. And we had psychological surveys, and we also had questionnaires to evaluate the different types of hardware, the location of the hardware, what was it like trying to get up and down the stairs, did you keep banging into things, how did the urinal work, for instance, was it comfortable to use, was it easy to use, a lot of human factors issues. The third category of medical experiments is very important, it will be very important for a long duration flight. It had to do with remote training. If you imagine an astronaut's going to be on station for 90 days, they've been training for 2 years, and maybe they can't fit in the training for every single test, all the way up to the last day. So maybe it's been a little while since they've seen a specific piece of hardware, or since they've read a specific procedure. They get up on station, 2 months pass, and then all of a sudden they have to perform this experiment. And this is an example of hardware that basically got sent into us in a pile. We've never seen it before. We don't know what it does or how it's supposed to be put together. And then we connect up with folks on the outside, either right through the internet on the World Wide Web, or we connect up with a two-way audio video, see you, see me camera type of thing. And here's Terry, he successfully assembled this. And then this is timed, and then there are questionnaires to evaluate all the procedures, and did we feel like it was easy to follow. From this experiment, we did find that the best way to do that was to talk directly with someone on two-way audio video, or to have a video showing us how to put things together. I'm going to take some questions as soon as we're done. As I mentioned, we had exercise 6 days a week. I've got to get back to it. We did the stationary bicycle 3 days a week, and we had a physician who actually came in and monitored us because it bumped our heart rate levels up a bit. We wore a heart monitor during that test, and you could see our heart rate. Then we also had a resistive device, which you don't see here, on the opposite side of the airlock, kind of like a little universal gym. And that was nice, and we could track how well we were doing and sort of challenge ourselves. Some folks use this mostly just to get it done, and other folks used it as a relaxation technique or to blow off steam. It was great to have the two different types of exercise. We have just had a food transferred in, and I'm putting things away in the pantry. As I mentioned, we use the space station-like foods. We had a food list to choose from. We had a 20-day supply of frozen food, which was resupplied 2 more times during the test, and dry foods, which would be similar to canned foods. Terry is using our reclaimed water here to mix up some soup. The water tasted great, by the way. It really, really did. And actually, Fred and I both prefer the slight iodine taste. You know, you get a slight chlorine taste to your water at home. Well, you had a slight iodine taste in here. We prefer that. Dinner was always together. Crew meals were prepared together at dinner and eaten together, and this was very, very important to check in with each other every day. Our technical guys sometimes were up later or might get woken up, and we also had to celebrate just a Super Bowl. Dave is a big Green Bay Packers fan, and he just blew off a lot of steam during the Super Bowl. I'm upstairs mourning the fact that the Patriots aren't winning. I'm from New England, so. And this, of course, are some of our folks outside. Doug Ming was the commander for the 30-day test, and John Lewis was in there. He's bouncing up and down. We always joke that he needs to go to the bathroom, and he's just too dedicated to leave that console. And as we come down to the end of the test, the folks for the Skylab experiment were in there for 56 days. 60 days was the longest time anybody had been in this chamber in this type of test. They really didn't know what to expect. So there was a very big celebration when we busted out of that tank. And we literally did. Dave had to back up and, throw the shoulder into it to get that door open. But we came out into the immediate area here, and all of our family members were there to have some private time with them, which was very, very important. And then we came out past our dignitaries here, and a lot of handshakes. And I cannot stress enough, some of the real important things in this test that we learned in doing this. First of all, it's very good crew selection. Spending some time with your crew up front and preparation. Try to imagine every scenario that might come up. We were also asked to imagine things like what if a family member passed away on the outside during the test, and things like that, things that we might have to decide whether we leave or not. Most of the folks you see out here in the high bay during the celebration, again, are support people. Friends and family, other co-workers that tolerated us being gone for 2 months. So that was really important to us. I do have a few more view graphs for you because we have some future things coming up as well. And this is important. This is actually part of the reason why I'm here today is to let folks know what's coming up and make some suggestions as to how some people could get involved. One thing I would like to point out in this test is that NASA, of course, is not just civil servants. For every NASA civil servant, you've got about at least 5 contractors. And these companies provided quite a bit of the hardware that we used in this test. So I just wanted to throw them up there because this was a huge collaborative effort, not just in in the Advanced Life Support Division, but also in some of the medical divisions on site at NASA. As of course, any test like this, or as the space station certainly will be. In the future, and the future is very close, coming up in late September, we have a 90-day single crew going into this chamber. We will be performing water recycling and air recycling, and we're also going to tie in the plant chamber. We'll be using one person's worth of oxygen from that plant chamber and supplying CO2 to them. We will also be harvesting some of the wheat that's in that chamber, making pasta and breads from that wheat. And then inside of the 20-foot chamber where the crew is, they will have a salad machine, and they will harvest some of the vegetables from that machine. In addition to this, we will have an incinerator, and we will burn the fecal waste and some of the solid plant material and return that ash into the plant beds. I have just a couple of slides I want to show you real quick. I'm going to go through them fairly quickly. They'll be doing some, I'm using 2A slides, the 60-day, but basically the 90-day folks are going to do the same thing. They're going to have medical experiments as well. This was a finger stick procedure that we had to do. They will be doing finger stick and actual venipuncture, blood drawing several times throughout the test. Certainly water samples are collected on all the water systems and some of the air systems. And again, they're a wonderful urinal. And I don't think they'll be collecting a urine sample every single boy goes through the test. But it really wasn't that hard to do. So we'll tie in our plant chamber for phase 3. This is not the actual salad machine. This is a much huger facility, but it gives you an idea of some of the things that have been going on. And then as we get close to a harvest, we'll go ahead and harvest some of that wheat and then use the incinerator as well.
Same size crew?
Yes, and same configuration, 1 female and 3 males. The down select to prime crew will occur on June 6th. We'll find out who's going in. I would have loved to have gone in, but apparently we can't do 2 consecutive tests in a row. That's just the way it goes. The way of the future, though, coming up after these 20-foot tests is our Bioplex facility. This is a large 5-module facility. We expect to have 3 modules up in preliminary testing in the year 2000. This facility will be built in the old human centrifuge rotunda in the building right next door to our 20-foot chamber. And this, of course, is going to be a fully enclosed life support system. No transfers in and out on this one. There will be 2 plant modules, a laboratory module, 1 module for housing all of the air and water recycling systems, and then a habitation module.
This is where the lab is now?
Yes. That's the building that it will be in. You can see the model of the 5 modules. The module in the back is the habitation module. And myself and a few other engineers did an engineering evaluation of actually living in there for a few days and taking a look at the layout and how everything worked and how that felt. And there are some design changes that definitely need to be made. It was a very worthwhile test. I'm glad we did it, and we'll be bringing that up to speed. And of course, I'd love to show this one, someday. There we go. And to give you a heads up on the most recent development just last week, it came down from our division management that we had been asked to build a prototype of the structure of what would be a Mars Transhab vehicle. This would be the transport vehicle that would take us to Mars, and we've been tasked in about a year to have a structural prototype built. So this 60-day test helped to really elevate the whole idea of going to Mars. And our Center Director, George Abbey's pretty hot on that, and we spoke with Mr. Goldman several times. So we're hoping there's some more Mars developments that are going to be on the horizon very soon. Ways that you can be involved in this or get some information. We have a phase 2A webpage. I have our web cards. Please get with me after the session, and I can do some of those. But we're also encouraging students to get involved and to do things like having a video telecon with us. We had grade schools actually perform experiments along with us during the test. This was great. We had another grade school who sent us tons of Valentine's Day cards, and that was really, really touching. But we want to ask them to maybe do some plant growth experiments or medical experiments. One school did a confinement study right at their school for a day, or perhaps get a college to mentor a grade school. And some of the types of things they can do is simple things like looking at different soil compositions or changes in light and water and temperature. We'll be testing different nitrogen fertilizers in our salad machine inside the chamber, and then stage planting. One that might be very fun would be figuring out how much soil or landscape you need to grow wheat from 1 loaf of bread. That might be kind of neat. And then certainly waste minerals from an edible plant material. And certainly medical studies as well. We had one school which did a sleep study, and they changed the light, they monitored their sleep and made records, and they sent us a little book about that, and that was just fantastic. So folks can do some medical experiments, and also questionnaires and data collection methods are critical. There's a huge amount of data that comes out of this test, and it's up here, right? So how are we going to get that out in a form that can be quantified and really shared with other people? And that's actually all I have for you today. Does anybody have any questions? Oh my goodness.
2 things. One is, were there any illnesses, any colds?
No. But in response to that, we've been asked about viruses getting into the air system. We had about 88 cubic feet of air in there, and some of that is diluted out, if you will, just from the volume of the chamber. And in addition to that, one of the wastewaters we collected was the humidity condensate. So that is going to go through a cleaning system as well, filtration system.
And the second thing is, you mentioned eating together. Were there any other times when you did recreation together, or did you have recreation time at all?
Yes, yeah. Friday happy hour was great. Of course, there's no contraband allowed in the chamber. And so happy hour consisted of grabbing every single munchie we could get our hands on and just laying it. We had snacks. Laying them out on the table. I mean, it just looked like this, really horrible feast. But sitting around and really just kind of laughing and joking about the week. We played a game of Risk. I almost got the total world nomination, but we gave up before then. And we played some Pictionary and other things like that.
No beer on Super Bowl Sunday?
And Super Bowl Sunday, we had some crew parties at day 20, day 40, day 59, day 30, the milestone, the mid-mark there, and of course Valentine's Day. We had this special Valentine's.
Were there communication delays programmed in here?
No, we're not. Although in the 90-day test, we may take a look at some things like blackouts, communication blackouts, and things like that.
How would you have felt about having to repair noisy or smelly equipment? Instead of having it sent out.
Right. We actually did have a situation where the drum that is used to vaporize the urine had to be opened up. And inside of there was still some liquid urine that had not gone through the system yet. And we had to pull that out onto the table. That thing was very, very heavy. It took all 4 of us to lift it. And we had, a small fan going, trying to blow it toward what we call the potty blower. Okay, there is a potty blower fan that vents that odor outside. So it's not pleasant doing it. It's necessary, and actually when we would have things like that to do, it was pretty challenging and kind of fun as a crew to solve those problems.
What new data resulted from this test as compared to combined habitability tests that have been conducted over the last 20 or 30 years?
Well, the goal of this test was to, in part, to take a look at space station developmental hardware, space station procedures, space station issues. So we used some of the specific hardware that's used up on shuttle right now. We used some of their procedures, and also to develop more remote training kinds of things. All the audio-visual interaction things are a lot newer, having the web and things like that. The water recovery and air recovery systems needed to be looked at almost individually. It's important when you do this type of complex integrated test that you add on individual items almost one at a time so you understand their
It
impact.
seems like you do a lot of venting and transfers in and out. Are there plans in the space station for that amount of venting? Or is that just
I don't know.
and your test is going to get more stringent as each
Well-
test you do is going to get more and more like real orbit conditions.
Well, of course, the Bioplex facility, there will not be transfers. Okay, and that's coming up in 2000. And that's more designed to be a full planetary outpost where your resupply is, however often someone flies to Mars. Part of the concern in this test was we had not done a test of that duration. We did not know what to expect, and the goal was not to try and fit 60 days worth of stuff in the chamber ahead of time. That could have been a different objective added on. It was not one of our objectives for this test. So we did have the 3 transfers a day. And the only thing that was vented was the methane gas that came off of our carbon dioxide reduction system. I'm sorry, go ahead.
How do you compare the carbon methane system you used versus the electron system they have now on Mir?
I don't know. I can't answer that. I'm not familiar with the Mir system. I'm now learning the air system that we have, and I'm sorry, I can't answer that.
And you said something about medical doctors coming in?
They did not come into the chamber. We were the only people in the chamber, but there were medical folks who monitored us during our bicycle exercise routine to make sure that our heart rate was in the proper range that it needed to be in. Yes.
I'm curious, since the plan is developed equipment for space station, has there been thought given to the equipment as a repairability on Earth?
Yes, as a matter of fact, there has been. Before this project, I was building biomedical hardware for station. And that was a big issue. The Human Research Facility module will be having biomedical hardware to evaluate a human's body in space. And from what I had seen in that work, they wanted to look at that as a program, so that you don't have 3 or 4 different oscilloscopes and all these different battery chargers and all these different things that everybody could use. So that will be looked at by program or by the overall station folks who want to supply basic tools. Some of that will not be done. Some of the hardware are commercial items that are being bought and packaged for space, and you really can't fix them because of the boards or whatever.
In particular, I was thinking about this tubing. I assume that they're directly welded. I didn't see any way that you could just...
The lines, the pipes and things like that? Yeah, some of that would need to be able to be, if you have a leak, for instance, you're going to have to be able to patch a leak and things like that. Yeah.
Why was it decided that the crew should be 3 male and 1 female?
The split on that's a good question. I think that came out of our psychological community. And I'd like to just mention something about that. It was a privilege to be a part of a test where it didn't matter whether you were male or female. However, and this is my own personal opinion, this is not NASA's words, but my feeling was, in this particular society, we tend to socialize our men and women a little bit differently. There have been psychological studies for the last 20 years where they take parents in with little boys and they ask them to complete a task and the parent helps them complete the task. They take a parent in with a little girl and the parent asks the little girl how she feels about completing the task. Now this has been done for the last 20 years and 19 out of 20 times those are the types of questions that are asked. And that's the difference between little boys and little girls and what the parents are asking them. One thing that I noticed in this chamber during a test was that if we had a problem, we had something that needed to be solved, that the guys tended to automatically say, this is the problem, this is how we solve it, let's move on. And that's important when you're in a can and you can't take up a lot of time being stuck on something because you have 3 other things to do. If I had not had that guidance, I might have wanted to sit and talk about it a little bit more. And I'm generalizing. I'm generalizing to men and women, and I'm not going to say everybody's like this, but I learned a lot from the guys in this can who were able to take a look at something, deal with it, and just move on. Because that's what you need to do. You need to hit a bump in the road and understand that it's not really that big of a deal, and you just kind of get on with it and get on to the next bump in the road.
Did you have any problems with parasites or insect?
No, we did not. Okay.
How did you prepare for the 60
Preparation, yeah. Of course, there's a lot of crew selection procedures, things like resumes and interviews. We spent about 4 hours doing psychological questionnaires, which were then all evaluated by the site group. We had private interviews with the site group, and we also did things like obstacle courses to see how the team would work together. And then pre-test, we were briefed on all the medical experiments and systems, and we defined roles for each crew member. This was key. Our 2 technical guys, our commander who handled management interface and some of the publicity and educational efforts. I had all the medical experiments, logistics, and scheduling. We knew exactly what we were supposed to be doing, and we knew who to go to for guidance on that particular area. I think we're probably done. Thank you so much.